In our first example problem from Chapter 9, we're given a sample of ammonia and told that it occupies 0.250 liters at 0.85 atmospheres and 27 degrees Celsius. And we're tasked with finding I wrote pressure, but we're actually finding the volume at STP, 0 degrees Celsius and 1 atmosphere. Now, in Chapter 9, we always want to get in the habit of working with the proper units. So we like liters for volume, we like atmospheres for pressure, but we want our temperatures to be in Kelvin. And to convert from Celsius to Kelvin, I add 273, right? So 27 degrees Celsius plus 273 is equal to 300 Kelvin, and 0 degrees Celsius plus 273 is easy, right? That's equal to 273 Kelvin. After that, right, I can use the modified version of the ideal gas law, which is P1V1 over T1 equals P2V2 over T2. Okay? And then it's just a matter of putting the units in the right place. I'll consider 1 to be my initial conditions. So P1, 0.850 atmospheres, okay. V1, 0.250 liters, over T1, 300 Kelvin, equals P2, that's 1 atmosphere. I don't know what V2 is, the final volume, that's what I'm going to be solving for, that's what the question asks for, over T2, which is 273 Kelvin. Okay. So I'll plug everything on the left-hand side, 0.85 times 0.25 divided by 300. Yep. That gives me 7.08 times 10 to the negative fourth. Now if I'm tracking my units there, it's atmospheres times liters over Kelvin equals 1 over 273. So that's giving me 3.66 times 10 to the negative third atmosphere over Kelvin times V2, right? I just combine these two terms here, 1 over 273. Okay. And then I divide both sides by my 3.66 times 10 to the negative third atmosphere Kelvin, which means my units, atmosphere and Kelvin, will cancel each other out, leaving me just with liters. And I get a final answer of 0.193 liters equals V2. That's the final volume that gas occupies at 0 degrees Celsius and 1 atmosphere. Okay? That should make sense that it occupies less space because we have decreased the temperature and increased the pressure.